Welcome to Study Loop.
So this question is asking us about the experience of effective nuclear charge by different electrons. So the question is asking which of the electrons experience a greater effective nuclear charge? Is it the valence electron in the beryllium or the valence electron in the nitrogen? And it wants us to explain the reason. So if you look at beryllium, beryllium is the fourth element in the periodic table. And if you write the electronic configuration for beryllium, you have 1s2, 2s2. Then the next one, then the other atom we have to compare it with is nitrogen. And nitrogen is the seventh element in the periodic table. So if we write the electronic configuration for nitrogen, it's going to be 1s2, 2s2, and 2p3. So which of the valence electron experience the greatest effective nuclear charge? Is it the one in the nitrogen or the one in the beryllium? So to start with, we first need to clarify what we mean by valence electron. So valence electron is the electron in the outermost shell, and the outermost shell in this case is the one with the highest principal quantum number. So the highest principal quantum number in beryllium is 2, and the highest principal quantum number in nitrogen is 2. But for the nitrogen, we have the division of the orbitals of the shell into orbitals where we have a 2s and then a 2p. So these are the valence electron in nitrogen. We have 5 valence electron, and that is 2 plus 3. And we have a 2 valence electron in beryllium, and that is the 2 from the 2s orbital. So one thing we have to think about is that the 2 electron for beryllium is in the second shell, and the 5 electrons for the nitrogen is in the second shell as well. But there is a difference in the effective nuclear charge that will be felt by the electrons in these shells. For nitrogen, we have 7 protons. So we have 7 protons in the nucleus. So if you draw like a schematic representation of the atom, you have the nucleus that contains the proton plus electron and plus neutron. And because the proton is positively charged and the neutron is neutral, if the total charge on the nucleus will be positive. So this is the first shell, and it has 2 electrons. And then the second shell, which in the case of beryllium, we have 2 electrons, and in the case of nitrogen, we have 5 electrons. So if we look at nitrogen, it has 7 protons, so it has plus 7 for nitrogen. So it has 7 protons, and then plus 4 for beryllium because it has 4 protons. So compare the charge of nitrogen to beryllium. Plus 7 is greater than plus 4. So plus 7 being greater than plus 4, plus 7 we attract the electron in the second shell more than how plus 4 we attract the electron in the second shell of beryllium. Therefore, the effective nuclear charge that is felt by the electron in the valence shell of nitrogen will be more than the effective nuclear charge that is felt by the electron in the second shell of beryllium. And that is just